So, imagine walking into a room, right? And every single wall, from the floor all the way up to the ceiling, is just covered in millions of tiny, disorganized sticky notes.
Oh, wow. Okay.
Yeah. And each note has just a single number on it, like a sales figure, a timestamp, maybe an inventory count.
It sounds incredibly overwhelming.
Totally. You're just standing in the middle of this room, and your boss walks in and says, tell me exactly what our profit margin will be next quarter based on all this.
Yeah, that's a recipe for instant panic. You'd
Yeah.
just be drowning in data.
Exactly. You'd be drowning. And yet, I mean, for so many of us, that is exactly what it feels like to navigate the modern business world. We are just constantly overwhelmed by the sheer volume of information we encounter every single day.
Right, because possessing data is rarely the same thing as possessing insight.
Yes, having a mountain of raw numbers is totally meaningless if you don't have a way to, give it structure. Which brings us to what we're doing today. Welcome to a brand new deep dive, everyone.
We have some really fantastic source material to unpack for you today.
We do. We're looking at a comprehensive article and an accompanying video presentation called An Overview of Mastering Microsoft Excel. It was produced by the Djere Services Group for the One Shot Computer Science podcast, specifically released on March 30th, 2026.
And the mission for this deep dive is to synthesize this massive guide. We want to understand how a simple digital replacement for a paper ledger basically evolved into the absolute foundational analytical ecosystem of modern business.
Setting the stage here for you, the listener, we really need to look at the actual mechanics of that transformation.
Right, we're exploring how this specific software architecture acts as a bridge. It takes you from that room full of sticky notes, that static, confusing data, and turns it into actionable strategic insights.
But before we can really appreciate the architecture we have today, we have to look back at the original problem it was trying to solve, right? Because the source material paints a pretty bleak picture of traditional record keeping.
Oh, it was brutal. Before the personal computing revolution, accountants were relying entirely on physical paper ledgers.
And clunky desk calculators.
Yeah, exactly. And the severe limitation of that analog system was the static nature of the information. I mean, think about the manual bottleneck involved in something as simple as a monthly budget.
Right.
If an accountant made a single error early on in a paper ledger, say they carried a 1 incorrectly on page 2.
Oh, no.
Yeah. Every single subsequent calculation that relied on that number was instantly invalidated.
They had to physically erase it all.
They had to get out the eraser and recalculate a cascading chain of numbers completely by hand.
That is essentially like building a massive house of cards. If you get halfway through and realize the bottom card is upside down, the whole thing collapses. You have to start completely over from scratch.
Exactly. Highly prone to human error and just incredibly slow.
So early digital spreadsheets, programs like VisiCalc and Lotus 123, they completely revolutionized the business world by tackling that exact bottleneck, didn't they?
They did. They introduced this groundbreaking concept of automatic recalculation.
And the source notes that Microsoft entered this space by releasing Excel 1.0 exclusively for the Macintosh in 1985.
Right, followed by a Windows release in 1987.
And what allowed it to just crush those early command line competitors was its graphical user interface. But beneath that accessible interface, the pull-down menus and all that, is the core solution the developers built.
What the guide calls the dynamic grid.
Yes, the dynamic grid. Explain that a bit.
Well, the dynamic grid is where the paradigm shift actually happens. Instead of typing static numbers, users build interconnected mathematical models. You use cell references and formulas.
So the underlying calculation engine is sort of mapping things out.
Exactly. It maps out a hidden dependency tree in the software's memory. It knows exactly which cells rely on which other cells.
Going back to that house of cards analogy, it's like having a magical house of cards. If you realize the foundation is wrong, you swap out the bottom card and the entire structure instantly rearranges itself.
Without collapsing, yes.
Yeah.
And that instantaneous recalculation at the architectural level, that's what allowed organizations to suddenly build incredibly flexible budgets.
They could actually forecast things.
Right. They could forecast complex financial scenarios, track inventory with unprecedented accuracy. A manager could ask, hey, what if our supply costs increase by 5%? And see the bottom line impact in a fraction of a second.
It fundamentally shifted the entire nature of business administration, going from reactive record keeping to proactive forecasting.
Totally. But Knowing that the engine recalculates instantly is one thing.
Hmm.
The guide actually breaks down the anatomy of how a user builds these models without getting lost in the data.
Yeah, they categorize this into three core pillars, and it starts with the grid and formula engine itself.
Right, and this foundational layer, it goes far beyond basic arithmetic. The true power lies in the massive library of mathematical and statistical equations running beneath the surface.
It's the core logic of the sandbox.
Exactly, processing complex statistical analysis and logical branching natively within the application.
But, and this is a big but, relying purely on the grid breaks down when you scale up.
Oh, absolutely.
The source makes it really clear that when you're dealing with massive data sets, writing manual formulas cell by cell is just physically impossible.
And pushing millions of rows directly into the grid causes severe performance issues. It'll just freeze up.
Which forces us to look at the second pillar, data processing and summarization.
Handling raw scale requires specialized tools built on top of the grid. PivotTables, for instance. They bypass formula writing entirely.
You just drag and drop, right?
Yeah, drag and drop fields to instantly summarize massive tables. It automatically sorts, counts, and aggregates the data in memory rather than on the sheet itself.
And then there's Power Query. The guide really emphasizes Power Query as an automated pipeline for importing and reshaping external data.
It's a game changer.
I like to think of Power Query as like an industrial water filtration system.
Okay, I like that.
Because you wouldn't build crucial business logic on dirty, muddy data, right? You don't want missing values, trailing spaces, or formatting inconsistencies.
You definitely don't want to drink muddy water.
Exactly. So Power Query systematically filters out the anomalies and standardizes the structure before the data ever hits your actual analytical pool.
And once that data is cleaned and aggregated, you move to the third pillar, which is visualization and formatting.
Making it look good.
Making it readable. This is the dynamic charting engine, turning processed data into bar charts, line graphs, scatter plots. And it also includes conditional formatting.
Oh, the color scales.
Yeah, using color scales to instantly highlight variances and outliers visually within the grid itself. High numbers are green, low numbers are red, that kind of thing.
So the Djere Services Group article stitches these three pillars together into a very specific 5-step workflow. Ingest, clean, model, visualize, and share.
It's a very logical progression.
Right. First, you ingest the data. That could be manual entry, importing CSV flat files, or establishing those Power Query database connections we just talked about.
Then you clean the imported data, addressing those missing values and text anomalies, filtering the mud.
Then comes the model phase. This is where the heavy lifting happens.
The math.
Yeah, you apply the specific business logic, writing the formulas to calculate profit margins, establishing moving averages, and deploying advanced lookup functions.
Like Excel lookup, to stitch disparate data sets together into a cohesive picture.
After the mathematical modeling is completely dialed in, you visualize it by generating the visual representations, the charts.
And finally, you share the completed workbook, usually to a cloud environment like OneDrive or SharePoint, allowing multiple stakeholders to co-author and view the insights simultaneously.
I think the brilliance of this specific 5-step workflow is how it forces the user to separate the preparation of the data from the analysis of the data.
That is exactly the point. By isolating the ingestion and cleaning phases from the modeling phase, it ensures that the insights generated at the very end are built on a highly reliable, reproducible foundation.
You're making strategic decisions based on a vetted architecture, not just messy guesswork built on raw, unfiltered exports.
Because this three-pillar system and the workflow are so effective, Excel has essentially been adopted as the global standard for corporate data management.
Everyone uses it.
Everyone. But that absolute ubiquity introduces some pretty severe vulnerabilities, especially when vastly different types of users are interacting with the exact same file.
Yeah, the source actually categorizes the user base into 3 main tiers, which I found really interesting.
So at the foundational level, you have administrative staff and data entry clerks. They're primarily logging daily activities, managing schedules, and tracking standard inventory with standard tables and simple arithmetic.
Nothing too crazy.
Right. Then moving up the chain, you have the financial analysts and data professionals.
The power users.
Exactly. The technical users who push the software to its absolute architectural limits. They are writing the intricate financial models, deploying deeply nested formulas, utilizing VBA macros for automation, and shaping massive data sets with Power Query.
And then at the top tier, you have executives and management.
Who are primarily just consumers of the data.
Right. They review the summary reports, interact with the dynamic dashboards the analysts built, and maybe adjust high-level assumptions just to see how those changes impact the bottom line.
Having all three of these tiers use the same software creates an incredible advantage, honestly. It functions as a universal business language.
Like a complex financial model built by an analyst in Tokyo can be opened, structurally understood, and modified by another analyst in London.
Without anyone needing to provision new, specialized software, it's a highly flexible blank canvas.
But that blank canvas is precisely where the primary drawback lies, isn't it? What they call spreadsheet risk.
Spreadsheet risk, yes. Because the software allows for complete freedom, it is alarmingly easy for a non-technical user, say an executive interacting with the dashboard, to accidentally delete a crucial cell.
Or worse, they might hard-code a static number over a dynamic formula.
Oh, that's the classic mistake, permanently breaking the dependency tree.
Like they might just type the number 50 into a cell that previously contained this complex interconnected equation.
And by doing so, they silently and instantly corrupt the integrity of an entire global financial model. No warning bells go off. The math is just wrong now.
That's terrifying.
It really is. And furthermore, despite how organizations often attempt to use it, Excel is not a relational database.
Right.
It lacks the strict constraints and schemas of a dedicated database, which is why pushing millions of rows causes slow performance, system crashes, and just completely unmanageable file sizes.
Okay, wait. I have a question then. If this software is so fragile that a single executive typing 50 over a dynamic formula can silently corrupt a multi-million-dollar corporate model, and the software crashes when you give it too much data, why hasn't the business world completely abandoned it? Why aren't we all just using dedicated, safer relational databases that lock down the rules and prevent that kind of user error?
It's a great question. And the business world continues to rely on it because of a fundamental trade-off. It's the trade-off between strict governance and extreme agility.
Okay.
Dedicated relational databases are incredibly secure, highly structured, and they can handle massive amounts of data. But they are notoriously rigid.
You can't just play around in them.
Right. They require specialized programming knowledge, like SQL, just to ask a basic new question of the data.
They can't just open it up and start experimenting with different assumptions.
Exactly. The spreadsheet remains the ultimate blank canvas. Its enduring value lies in its remarkably low barrier to entry.
So that executive in London can tweak the analyst's model from Tokyo on the fly.
Yes. Testing new scenarios instantly without needing to submit a ticket to the IT department to run a custom database query. Organizations accept spreadsheet risk because the speed, the universal accessibility, and the rapid prototyping it provides simply cannot be matched by heavily governed, rigid database systems.
It's a calculated risk for the sake of unparalleled agility. I get that.
Yeah.
So having weighed those structural risks and rewards of this massive proprietary corporate tool, the final section of our source material takes a really surprising turn.
It does. It looks at the open source origins of how this specific guide was actually made, accessible ways for you to practice, and how the platform itself is rapidly evolving.
The meta-production notes included in the Djere Services Group article present a fascinating juxtaposition, I think.
Totally, because this entire comprehensive guide about mastering Microsoft Excel, which is arguably the ultimate closed-source proprietary corporate software, was produced using exclusively free and open-source software.
Yeah. The creators used pop.os GNU Linux, which is a custom Ubuntu distribution, as their primary operating system.
And they utilized open-source tools for the entire production pipeline. They used GIMP to create their visual assets and thumbnails, and Shotcut for their video editing.
They even used an AI tool called Notebook LM to generate the conversational audio elements for their presentation.
Which is an incredibly innovative way to process and present research.
It really is. And this open source ethos extends to their recommendations for how a beginner should actually start learning the platform. Because, even though the desktop application is part of the paid Microsoft 365 suite, there is a highly capable, completely free web version available.
Right. And this is particularly useful for Linux users. If you are running an operating system like pop.os, you don't need to go through the complex hassle of provisioning a Windows virtual machine just to learn spreadsheet architecture.
You can just do it in the browser.
Exactly. The web environment allows you to interact with the grid directly.
And the guide stresses that you cannot learn this architecture just by reading about it.
No, definitely not.
Beginners are encouraged to visit public repositories like Kaggle, download free raw data sets on topics that actually interest them, and just start building.
build your own pivot tables, build your own formula-driven dashboards. Hands-on practice is essential because the platform is undergoing a massive architectural evolution right now.
Oh yeah, the future of the spreadsheet.
Microsoft is actively bridging the gap between the spreadsheet and advanced data science by integrating modern programming languages directly into the grid.
Python is now integrated natively into the Excel environment.
It's huge. You don't have to export your data to a separate development environment anymore.
Because Python is like a powerhouse programming language used extensively for machine learning and advanced statistics,
Right,
right?
exactly.
Mhm.
By merging its capabilities with the spreadsheet, analysts can now execute incredibly complex data science tasks. They can run predictive models, process complex data structures natively within the familiar visual environment of the grid.
And beyond Python, there is the integration of Microsoft Copilot, bringing artificial intelligence directly into the formula bar.
This is wild.
It really is. Instead of furiously searching the internet trying to remember the exact syntax for a deeply nested function, you can just use plain English. You type, highlight the top 10% of sales, or extract the text from this specific column.
And the AI interprets your intent and executes the syntax automatically. It acts as an interpretive layer, translating natural language into complex programmatic code.
It's basically like having a bilingual translator sitting next to you who speaks fluent spreadsheet.
That's a great way to put it.
You just tell the translator what you want to accomplish, and they handle the heavy lifting of communicating with the machine's calculation engine.
We are witnessing a monumental shift here. A platform that replaced the paper ledger is now opening its borders to Python and generative AI. The barrier to entry for executing advanced data science operations is being dramatically lowered for the everyday business user.
It's truly amazing. But, information alone, raw numbers scattered on a million sticky notes, that will never be enough to drive success.
No, it won't.
But by understanding the architecture of these dynamic recalculating models, you can fundamentally change how you extract meaning from your data. If you haven't yet, seriously, grab a raw data set from Kaggle and start exploring the analytical sandbox today.
And I'll leave you with this final thought. As Microsoft Copilot and integrated AI take over the highly mechanical tasks of writing complex formulas and Python code within the grid, it really forces us to reconsider the role of the human analyst.
Oh, that's interesting.
Yeah, will the defining skill of tomorrow's business leaders shift entirely away from knowing how to build a mathematical model and become purely about knowing what questions to ask the data in the first place?